So now we're looking at verifying identities, and so we want to use all of our algebra skills, all of our identities that we've talked about, to make one side look like the other. So what do I mean by that? Let's say I have 1 plus secant of x, sine of x, tangent of x equals secant squared of x. And I want to verify the identity. So I want to show that this is true. I want to prove that this is actually true. That 1 plus secant of x, sine of x, tangent of x is actually equal to secant squared of x. So whenever we're verifying the identities, one thing that you want to do is start with the more complicated looking side, right? So I have the left side, and then I have the right side. Trying to go from secant squared to the left side is going to be very difficult. But I have a lot of identities that I could use to simplify the left side and at least give me a starting point to break it down to look like secant squared. So one of the first things that I'll do, I want to transform everything on the left-hand side to terms of sine and cosine. Okay? So I have 1 plus secant in terms of sine and cosine. Secant is the reciprocal of cosine, so I have 1 over cosine of x times. Sine is already in terms of sine and cosine, so I'll leave it alone, but I will write it as a fraction, sine of x over 1, times tangent in terms of sine and cosine. Tangent is sine over cosine. And so again on the left, I now have 3 fractions that I'm multiplying together. So I'm going to multiply the top times top, bottom times bottom. So I get 1 plus 1 times sine gives me sine squared of x over cosine times 1 times cosine gives me cosine squared of x. Now again, identifying identities, I have sine over cosine. Right? I know they're squared, but that's all right. Sine over cosine, you recall, is tangent. So sine squared over cosine squared is tangent squared. So I have 1 plus tangent squared of x. And if you recall your Pythagorean identities, 1 plus tangent squared is an identity. It is equal to secant squared. So I can use my Pythagorean identity at the end. 1 plus tangent squared by the Pythagorean identity is in fact equal to secant squared. And so I've made the left look exactly like the right-hand side. And so I verified this identity. They are true. Right, so this is what I was saying about whenever we're verifying the identities, I have an end goal in mind. I know what I'm trying to get to, what I'm looking for. Okay. All right, let's do another. All right, so again, I want to verify the identity. All right, so I have cosine of x over 1 minus sine of x equals 1 plus sine of x over cosine of x. Now, in the previous example, I said to start with the one that looks most complicated. Looking at both of these, they're both fractions. They look about the same amount of complicated. All right. Depending on what the equation or the identity looks like, it's going to dictate how you go about solving it. If you have fractions on either side. Okay? It really does not matter what side you go for, but one good way to go about solving this is looking at what my end goal is. If I start with the left-hand side, I need 1 plus sign on the top at the end, right? So I'm going to go ahead, I'm going to force the left side to have 1 plus sign on the top. So I'm going to take the left side, and I'm going to multiply top and bottom times 1 plus sign. That's what has to be there, so I'm going to put it there. So I'm going to take this left side, and I'm going to multiply the top times 1 plus sign of x, and I'm going to multiply the bottom times 1 plus sign of x. Now I have cosine of x times 1 plus sine of x over, on the bottom, 1 minus sine of x times 1 plus sine of x. If you recognize this, or it'd be a good idea to start recognizing this, I have the exact same thing, but one is minus, one is plus. This is the factors from the difference of squares. So you can multiply it out, but you're going to end up with 1 minus sine squared of x. And if you recall earlier, we looked at manipulating the original or the main Pythagorean identity. Sine squared plus cosine squared equals 1. If I subtract sine squared from both sides, I get cosine squared is equal to 1 minus sine squared. So 1 minus sine squared is equal to cosine squared. So I get cosine of x times 1 plus sine of x over cosine squared of x. Now on the top, I have two things being multiplied together, so I have one complete term, and on the bottom, I have one complete term as well. Here I have one cosine, here I have two cosines, so one of them will cancel out. So this cosine cancels out one of these cosines. So I have 1 plus sine of x over that one remaining cosine of x. And if you look, that is what I was trying to get to. 1 plus sine of x over cosine of x. So the left side is equal to the right side, and I have verified or proved this is an identity.